Hello everybody, this is 2015 BC question number 6. It looks like it's not too bad. We want the ratio test just to find the radius of convergence. We don't have to find the interval, so it's a little bit easier. So we need our a sub n term, and that's just given to us very nicely, like such. So we need a sub n plus 1, replace all the n's with n plus 1. Then we have to find a sub n plus 1 over a sub n. So we will do that. But when you divide by a fraction, you multiply by the reciprocal. So that's going to be n over negative 3 to the n minus 1, x to the n. Now the fun part. Looky here. You have n minus 1. Which one has more, the top or the bottom? Clearly the top has more because the bottom's n minus 1. How much more does the top have? It has 1 more than the bottom because the bottom you subtracted 1. So when you cancel those out, you're going to be left with one of these. And similarly, the x to the n. The top has 1 more than the bottom, so on the top you're left with one of those. So this all equals negative 3xn over n plus 1. So what does the ratio test tell us? The ratio test says you find this thing called r, which is the limit as n goes to infinity of the absolute value of this ratio, which will be this. Now if you look in this limit, n is changing. So x is a constant. So I can take the negative 3x out in front and take the limit of the remaining. But this is just 1. You can use L'Hopital's, you can divide everything by n, take the limit by whatever method you want. That's clearly 1. So the answer is 3x, absolute value. And the ratio test says if the absolute value of r is less than 1, then you have a convergent series. If that is greater than 1, it diverges. The first one I hope I said converges. If it equals 1, it's inconclusive. You have to try something else. So the radius, we're not in the proper form. We have to divide both sides by 3. So we get absolute value of x is less than 1/3. So that's our radius. So our radius, r, is 1/3. That is part A. So part B, ooh, I should have boxed this out. Bam. Part B, so you want to find the Mclaren series for f prime. So here's what we have. We have the Mclaren series for f. That is x minus 3/2 x squared plus 3x cubed minus ... plus negative 3 n minus 1 n x to the n plus ... So, they want the first 4 terms. And first 4 terms. No, first 3. 4. I can't read. 4. Oh, but they don't want the general term, eh? That makes this so much easier. So let's find the next term. So to find the 4th term, we got to make n equal to 4. So if you make n 4 here and here and here, you will get minus 3 cubed x to the 4th over 4 plus ... So here are the rules. You do 5 things. There's 5 things you do to a series. So the derivative is 1. So the derivative of the function, if you knew that function, is the derivative of each individual term. So it's 1 minus 3x plus 9x squared. Whoa, why is that 3 cubed? Oh, I'm okay. That's 27 times 4. The 4 is going to cancel. It's going to be 27x to the 4th plus dot, dot, dot. Oh, no, no, no. I forgot to decrease my exponent by 1. Yoshida. All right. I think we're good at this point. So that is f prime. But then here's the part that freaked everybody out. Express f prime as a rational function. So you have to actually find the function that f prime of x equals. We have the series. So here is what you would have to recognize. This is 1 minus 3x plus 3x squared minus, or actually, yeah, we can deal with that. 3x cubed plus dot, dot, dot. Well, I probably should have put the negative inside the parentheses. Yeah, let's do that. And that's plus negative 3x. So you have to recognize this is a geometric series. Geometric series. So when you want to convert a series into a function, you have to recognize it as either a cosine, a sine, a e to the x, geometric, one of those. And this is geometric. Your r is negative 3x. Oh, I should put a minus there. Minus 3x, that's your r. And so your sum of an infinite geometric S sub n will be f prime of x. Is the sum of the infinite geometric S sub infinity. It's the first term over 1 minus your r. So that's the sum of an infinite geometric. But that only works if the absolute value of r is less than 1. I don't think they asked for that restriction. But this would have to be true. So divide by 3. So that would be the interval of convergence. But they didn't ask for it. I just threw that out as a extra bonus for you guys because I know you love extra work. All right, for part D, or C, you do not have to have memorized the basic series for sine, cosine, e to the x, and geometric, and all those things, but they could have you create it from scratch using the basic formula of All-Taylor. So if they did, you would find e to the x is this. So we start with e to the x. Then they want the third degree Taylor polynomial for g of x. Did we find that already? Oh, so here we go. We have, let me do it in a different color. We have f of x right here. We have e to the x right here. So they want to multiply these two together. Here's what's happening. So g of x is e to the x times f of x. Well, we have to multiply these Taylor series together. Normally you can't do it because if it's infinite, how do you multiply an infinite number of terms? So it's going to be craziness. But, whoa, that's craziness there. But they only want the third degree up to the third power. So we're going to do, okay, this is going to get really messy, but I am going to do for you distribution. So I need to distribute this x here to this, to that, to that. I won't do this one. Why? Because that'll give me a fourth power, and we only want a third degree. So let me distribute those. X times 1's x, x squared, and x cubed over 2. Then I'm going to take my next term and distribute, but I'm going to stop at 2 because the third one will give me a fourth power. So negative 3 halves x squared times 1, and I'm going to line it up in the squared column, and then as I distribute to the next one, it's going to be negative 3 halves x cubed minus 3 halves x cubed. Is that right? Negative 3 halves x cubed, I think so. Oh, plus, 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 plus. Minus, no, minus. No, yeah, minus, minus. Minus, minus. Okay, we're good. And then let's go to the next one. I'll do it in purple. So I multiply by the first one, that's third power. I won't do the next one. If I did this one, I would get a fourth power, and that's too big. And so 3x cubed times 1, I'm going to put it in the x cubed column. And I'm going to add these up. So I don't have to go further because that has a fourth power already and they only want a third power. So we're done. Just combine like terms. So first column I have an x. Next, I have 1 minus 1.5. So it's minus 1/2 x squared. Then I have a half minus 1.5. So it's minus 1 plus 3. That's plus 2x cubed. I hope that's right. That is right. I'm looking at the answer. Bam-o. That's it-o. See you, you kiddos.